I'm Dave and welcome to my shop. Today is all about what it takes to blueprint and accurize rifles. Come on in and sit a spell. Why, hello everyone and welcome back to the shop. Today I figured what we're going to do is I've got most of the components for my Remington 700, the rebarreling. If you remember in a couple of previous videos, I had mentioned that my 308 that I've had forever and ever is shot out, and I've got to get in there and rebarrel it. And I've kind of taken that to an extreme where it's going to be kind of an interesting project. I'm going to talk about the actual process for blueprinting or accurizing the rifle and what we're going to cover. This is going to be probably a longer video because there's a lot to that. And I get asked about that quite a bit. So let's get over to the bench and get going. Okay, so we're going to talk about the process that I go through to accurize, blueprint, whatever you want to call it, the factory action. Mostly this is to answer questions, give an idea on the process that's involved or what's involved. And the other deal is when we actually go to do the work, I just want to be able to do it. So we get everything stripped down. We have the firing pin assembly out of our bolt body. Our bolt body should be completely stripped. You'll notice that this has the ejector still in it. That's going to be fine for the purpose of this video. So when it's completely stripped out, the first thing I'm going to do is I'm going to look at my firing pin assembly, and I'm going to look for I'm going to look at the spring. I'm going to make sure that the spring isn't real excessively snaky or coil bound. I want to make sure that it slides in and out of the bolt body easily. This one's starting to grab a little bit, but this hasn't been messed with in 20-25 years either. Other things I'm going to look at is the firing pin tip. I'm going to check that for dimension, as well as inspect the tip for flat spots or shiny spots where it's been hitting on the firing pin hole. When the firing pin is in the cocked position, it is not supported, so it can drop down, and when you fire the rifle, the firing pin moves forward and it can strike the bottom of that hole before it travels through it. If you have any of those conditions, you definitely want to take care of it. If those all check out, then what I do is I'll break down the shroud and the cocking piece to just the firing pin. I'll put that in the lathe and check it for trueness. Want to make sure it's not bent. If it's bent, it's going to get replaced. If I have to do any kind of work to it, I can regrind the firing pin tip. I can recontour it. I can do all kinds of things. If it's striking on the firing pin hole, I can do a process of what's called bushing the firing pin, and what I'll do there is I'll basically make a 250-300 thousandths bushing that presses into the bolt body and encapsulates the firing pin so that way it's running true 100%. Now there's some things when you do that you have to be aware of. This firing pin is tapered, and this is designed to be a stop. So when you bush it and you encapsulate the firing pin, a lot of times you have to relieve this area to allow the firing pin to travel further. So that's what you would do. if you're not used to doing that and you have any problems here that need to be addressed, I would strongly recommend you get a hold of Greg Tannell at Grattan Rifles, and he makes a complete assembly. And this has got some really cool features. He makes them in the bright, in the satin black, long, short, small firing pin diameter, large firing pin diameter, and you can see that they are long enough to where you can still go ahead and bush the firing pin hole so that it captivates the firing pin. Some other neat features about this is the actual firing pin itself has been spiral fluted, and that is opposite the way the coil spring is wound, so that when you, in the cocked position, the spring is compressed. As you fire it, the spring unwinds with the fluting, and the idea is to reduce friction. It's a very good design. These run about $100, depending on where you are in the world with shipping. Worth every penny, and they fit very nicely. You can see that that's a very smooth fit. Best bang for the buck right there. That being said, once I've taken care of everything to do with the firing pin assembly, the next procedure is, this is a V-block that I've made, and this is set up to handle long and short actions, and its sole purpose is to secure the action. That way I can move this to my bench vise. A bench vise has an anvil where I can attach my indicator on a magnetic stand, and what I'm doing when I do that is I'm measuring play in the action to bolt raceways. I don't really concern myself with back and forth action at this point. What I'm worried about is more vertical play. That's up and down. And what I'll do is I'll check that in the front and in the rear of the bolt, back here and up here. And typically what you'll find in factory actions is you're going to run anywhere between 3 to 10 thousandths worth of slop in that raceway. The reason that I look at that is we've taken a great deal of time and effort to be able to dial everything in to true concentricity and true center, so that we can remove to a very high degree stackable tolerance, i.e. this shoulder is parallel to the face of our barrel. Our breech is perpendicular to our threads, is our tenon shoulder here is parallel to our recoil lug, is parallel to our action face, is parallel to our lug abutments, and so on and so forth. If you have all this play here, you lose that. And how you lose that is through the trigger assembly. So you have a cocking piece on your firing pin that interacts with the upper sear of your trigger. In the cocked position, this is under spring tension and forces everything up, and it introduces cant into the bolt body, and so this will move slightly down, and that can cause light strikes, misfires, reduced energy, not hitting the primer in the same place all the time. You know, the point is we've spent a lot of time to be able to get things on center. And what's interesting is people will lap lugs because we want 100% contact, which is true, But even when you lap those lugs, if you do it properly in the working position, which means you have the cocking piece and a trigger in there and you're lapping your lugs, you're lapping that to a cant. So yes, you get 100% or 75% or better bolt lug contact, you're still on a cant. The way you can fix that is through a process called sleeving the bolt, and that's what we're going to spend some time talking about. Back in the day before custom actions, this was a really popular thing to do. I think it's kind of gone by the wayside with the uprising of custom actions. There's some affordable options out there, but it can still be pretty pricey. You know, depending on who you're dealing with, this can be done fairly economically. So what the process involves is you're machining either the back of the bolt. I like to do a double sleeve, and we'll talk about that. But you're going to machine the bolt down, secure sleeves that are a greater diameter to the bolt, and then machine those surfaces down to where they're within 1/10 or 2 of the raceways in the action. Now, what used to happen in the old days is a lot of Remington actions, the front receiver is a larger diameter than the rear raceway. And so if you sleeve the front and the rear, your bolt would jam up. So along comes a guy by the name of Jim Borden, and well, let me back up. So the fix for that was to just sleeve the rear of the bolt only. That would fix a lot of the trouble, but you'd still have a little bit, you know, if you had 5/1000 front and rear and you got this squared away, you know, and was held straight, you'd probably still have 1 thou or 2 in the nose worth of play. But because of the difference in diameters, that's about the best thing you could do. Well, then along comes a guy by the name of Jim Borden. He's a bench rest Hall of Famer, a tool and die guy. He's a mechanical engineer, and he builds some mighty fine actions, Borden actions, fantastic actions. Well, anyway, he came up with the idea of the Borden bump. And this is my interpretation, or this is how I interpreted that idea. What he figured out was in lockup, the critical area was right behind your lugs, and that this area of the bolt, i.e. this is the locked position, this is the unlocked position, this area of the bolt didn't matter. So you could double sleeve a bolt and then file, stone, machine this excess part of those sleeves down, and it would run very smoothly. It would lock up very nicely to where you wouldn't have cant, and you could remove the bolt. That's a great idea. And what you would do is you would take bushings and you'd figure out the sizes of those, the diameter of the sleeves you needed, and you would machine those sleeves accordingly, and then machine the excess areas that you don't need away. And what that left you a lot of times with is with a sleeve on this area and this area that we're just going to use arbitrary numbers that might be 703 here and maybe 702.5 back here. Then sometime along comes another fella by the name of Greg Tannell, and he's another very well respected and well known riflesmith as well as a tool maker himself, and he came up with a mandrel system that would allow you to uniform the raceways, i.e. you would basically machine these out to the most common sizes is a 703 or a 705. And that way you could have the same front and rear. And then you didn't have to worry about board and bumps. You could just double sleeve, turn it down to, let's say you machined, let's say this was a 701 and a half raceway, and this is a 702 raceway. You would machine both raceways to a finished dimension of 703. You'd attach your sleeves, you'd machine your sleeves to basically 702 and a half or better, you know, a tenth or two less than 703, and you would get a very nice tolerance with no cant. The problem with that is if you're a bench rest guy, it was never a big deal. But if you were a hunter, you would feel that transition on the sleeves. And if you were in a panic situation, you could catch that. No, I shouldn't, panic is a bad word, but let's say you're on a hunt. You've been tracking this big bull elk for a week. You finally got a good shot and your adrenaline's going. You shoot, you need to make a follow-up shot, or whatever happens, the adrenaline's pumping. You go to cycle your bolt and it locks up. That's what would happen on that sleeve right there. The fix for that is pretty simple, is you go back to the board and bumps. Is you could machine that uniformly and then relieve that area of material that is arbitrary, it's not needed, to where the bolt still runs very smooth. You don't feel the sleeves. There's no binding or lockup, but yet in the locked position, there's no cant. That's how I like to do that. So it's a kind of a hybrid method of uniformity that creates ease and ease in your operations. You don't have to think about a bunch of things as much, and it's just uniform. This is important to get this right. So you've got to get your sleeve. If you only have one lathe, I'm lucky I have several, but if you only have one lathe, you need to have your sleeves made, because you only want to set this bolt up once. So once you get the bolt set up, you can machine the bolt body down, fix the sleeves. That's going to take you about a day. It has to sit overnight. Then you can turn those down to your finished diameters, machine the back of your lugs, do a cleanup pass on the front lugs, the bolt nose, and square up the bolt face. Before we go to the barrel work is once the bolt work is done, then I go to my truing or blueprinting of the action, where I'll get this set on its true center, front and rear, and get that dialed in perfect. And then we'll go through the process of opening up the threads and truing the threads, squaring up the bolt face, and squaring up the bolt lugs. When you do it that way with the sleeves, you don't need to lap the lugs because there's no cant. Everything it's perfect. So we've done all the work. Everything is nice and square. The final thing we need to look at is this little bit of back and forth play here. And I think a lot of people kind of overlook that. And what that has to do with is the relationship of the upper sear to the cocking piece. We've moved everything back in the action, but we've moved, in essence, the locking lugs forward on the bolt when we trued those up, even if it's just a few thousandths. And the way this works is on a camming motion. You can either, this is the camming action that we're talking about right here. When you move that back too far, you'll get a double click because you're not utilizing that cam anymore. And so the way you would fix that is you would either build that up on one or both with TIG and remachine it if you're pretty handy. If not, you can, on these are silver soldered, you can heat that up and move it forward so it works. But basically the magic number is 10 thousandths right here. As long as that's good, you're in good shape. And that's assembled. Outside of that, from there, once all your action and bolt work is done, you'll get everything, you know, it'll still, you won't have your firing pin assembly in it, the ejector will be out of it. How you check that is this will all get mounted back in the block, go in a vise. I can take a depth micrometer and go right across the face of the receiver in relation and measure that to the relationship of the bolt face, and that should be, I use a 10 thousandths indicator for that, and that shouldn't show any deviation. It should be, you know, if there's no movement, you're a tenth or better. You can't be better than the resolution of your equipment that you're measuring with. I'll show you that when we get to it. But basically, I don't want any movement across that plane, across the bolt face. Then I'll measure from the receiver face to the bolt nose. And if I'm 0 here, I should be 0 over here, 0 all around the bolt nose. What I've done is I've eliminated all of that cant and that tolerance to where everything just plays very nice and everything is very well aligned. I do check, if we're using a custom action, you're still going to go through that process and verify that that custom action is what it should be. Most of the time they are. On occasion, it wasn't that long ago, I was building a 6.5 PRC for a guy, and we had it was a very good client actually, and we had the action, and the box said medium action, magnum bolt face. I went through my checks, come to find out the bolt was a standard bolt face, which the standard bolt face is a 480 diameter bolt face. The 6.5 PRC uses a magnum bolt face, which should be about 545. So that would have really raised hell with head spacing and all kinds of stuff if I hadn't have caught that. Not to mention it, you know, it possibly could have cost us a barrel, but we caught it, got it sent back. It took about 2 months, but everything came out in the end correctly. But that's why you check and double check everything, even if it's new. So once we've verified all of our measurements to be true, this will stay right in the vise just like that, and from there I can go ahead and start calculating and creating my drawing for the chambering operation, i.e. tenon length, diameter, head space, and all of those things. But that's basically what I'm looking at when I accurize or blueprint an action. It's pretty much stem to stern. I want to get rid of as much tolerance as I can in the entire system to get everything as true and as concentrically aligned as possible. So from here, in the next couple videos, that's where we're actually going to start this series. We'll start with the sleeving and bolt operations, and we'll move right on through. I'm really looking forward to that. That's going to be a lot of fun. Any kind of specialty deal that we're going to be using, I'll show you how to make or talk about where you can get it. Anyway, that's about it for this video. I hope you enjoyed it. I hope it provided some insight on the process I use for blueprinting and accurizing actions. And if you have any questions, don't hesitate to reach out, and we'll catch you next time. Thanks, everyone.